All right, this is a problem that we didn't get to yesterday. I did with some of my classes. Elizabeth, you're right back there making noise. She wants to be on film. She's a very frustrated actress. So when I'm filming, she likes to throw things around the classroom. Let's do something a little bit more exciting today. Let's play some music. Yeah, we haven't done that in a while. Okay, let's play some music, and let's see what we got here. Okay. Saw? Is that like a song? Saw? Saw?
Play some Doors.
Doors?
Yeah.
No, I want to play some. I want to play this. I play this a lot.
Play some Windows.
All right, here we go. Rock and roll! A little more exciting, huh? Who's absent today?
Max A.
Just like, okay. Who sings this? AC/DC. One of the, I don't know if this is the one, but AC/DC has one of the best-selling albums in history. One of the, yeah. Ah, I feel so much better. Okay, now, I have a piece of metal that's behind me on the board, okay? The dimensions of the metal are as follows. It has a mass of 125 kilograms. It has a radius of 10 centimeters. And it has a height of 2 meters. Yes? Understood? Now, I want to do two things. First thing I want to do is I want to know what the pressure is. What's the pressure? What's the pressure that this cylinder exerts? This is going to be sitting on a table. What's going to be the pressure the cylinder exerts sitting on a table? Okay? Now, pressure is force per area, correct? Force per area or rho GH. Either one, right? Yes? Okay, now. So, that's going to be, let's use a different color now. Excuse me. Oh! Okay. Tired already. Okay, so it's going to be force over unit area, right? So what's the force going to be? mg, right? Over A. What's mg? What's mg going to be? Well, it's 125 kilograms. That's M. What would mg be? What would the force be? 1,250. 1,250, right? You with me? 1,250 what? Mickey? Newtons. Very good. A little coaching. Yes, it was better. That was better. That was better. Yesterday I asked him how tall he was, and he said 120 pounds. So that makes a lot of sense. Okay? Now make sure that you don't go faster than the speed limit. The speed limit is not 50 miles an hour on 35. It's 20 pounds. Okay, that's the speed limit. It's 20 pounds on Highway 35, okay? If that makes sense to you, that's not good, okay? Now, so this is going to be pressure is going to equal 1250 newtons over what's going to be the area? What's the area of a circle? Area of a circle. Area of a circle is going to be pi r squared, correct? Is the height necessary for this? No. No. Could be later on, could be, right? Right? So it's going to be 3.14 times, what's the radius?
10.
What's the radius? Okay, Mr. I'm 6 foot. That's how much you weigh.
It's 10.
Is the radius 10 centimeters? Or is it really? Really? Now it's 10 centimeters. That makes as much sense to me as saying that the radius is 50 pounds. You're just as correct. Oh, what? What's the radius? What's the radius in standard units?
No, because it was like it says 100.
0.1 meters.
0.1 meters, right? Okay? If you called it 10 centimeters or called it Alice, you're just as wrong. Okay? Call it house. Okay? Say house. That's right. You're just as wrong. Okay? So it's going to be 0.1 meters. So 0.1 meters squared. Correct? So what is 1,250 divided by pi r squared? So how would you do that? You'd say 1,250 divided by 3.14 divided by 0.1 squared, or 1,250 divided by, open parentheses, 3.14 times 0.1 squared, close parentheses. Either way, it's the same. What do you got? Give me a big number.
39,809.
39,809. Okay? If there's a knock on the door, that means it's the significant figures police. 5 significant figures? I know. You don't need all that, but that's okay. She doesn't feel good about herself, so in order for her to feel good about herself, she simply uses an enormous number of significant figures. Like when you want to feel good about yourself, you simply use the wrong unit labels, okay? Right? So like I'm Irish American, so when I'm not feeling good about myself, I say that I'm Russian, okay? You get it? You get it?
Mm-hmm.
Yeah. 18,000 what?
39,809.
39,809. 39,809. Right? Mm-hmm. Or just 40,000 would be fine. 40,000. Okay. And what are the unit labels for that? Mickey? Pounds?
No. Pascal.
Feet?
Pascals.
You got it right! Pascals. Excellent. Pascals. And who's Pascal's named after? Mr. Pascal? Yeah, right? This guy's name. What's his first name for extra credit? Wait, saying a bell? That bell didn't mean begin thinking. That's just Albert? You're close in terms of
I got this.
Peter? No, you're way off. I mean, Albert's not really close, but if Albert starts with an A, you know, his first name starts with something near an A, as opposed to Peter, which is definitely wrong. Charles. It's good. That's a good one, like Charles.
Hold on. Benjamin.
And what is Charles Law named after? Mr. Charles?
Mr. Charles.
Mr. Charles?
Great Charles.
All I wrote down was Pascal's principal.
No, it's
Blaze,
not Mr.
Blaze,
It's
Blaze.
It's not Mr. Principal.
Blaze.
It's not Pascal's principal, and his first name is Pascal, and the second name is Principal.
No, Blaze.
His name is Blaze. I like to say BL word. Blaze. I like that. Blaze. Blue.
It's
Blaze.
right
Blaze. He's
Pascal's
not kidding.
principle was
It's really
discovered in the
Blaze.
17th century
See how
by
that was
Blaise
close to
Pascal.
Albert? Okay? Now, all right?
Extra credit.
I mean, no, he's pointing to the top of his head. He wants extra credit put there, not on his grade. He's like pointing here. So, see, I have hair. See, I have hair. I don't have hair, but he does.
Blaze.
Yeah. So Blaise Pascal. Now, what's the density of this material? What is the? Can I erase this?
Yes.
Can I erase that?
Yes, you may.
What's the density of the material? Isn't density simply mass over volume? Isn't it? Right? Easy?
Yes.
So we know that it's going to be 125 kilograms over pi r squared h. pi r squared h, okay, of a cylinder. I got to change the A to what? A V. Volume of a cylinder is pi r squared h. So it's going to be 3.14 times 2 times 0.1 squared. What do we got? What do we got? And then what is it? What do you think it is? I mean, let's say it's yellow. It's yellow metal. That'll help. What do you got?
Gold.
She says gold, right? That's you know what that's called? That's called confidence. It's gold. It's not aluminum with yellow paint. It's definitely gold. It's confidence. Excellent. So what's the density of the metal?
0.0628.
0.0628. House.
0.0628.
No. Does that make any sense to you?
It does not make
That like 125 divided by
Oh, 7,000.
really small numbers.
That's why.
7,961.
7,000, what is it? 125 divided by 2 divided by 3.14 divided by 0.1 squared, right? Are you with me? Is going to be what?
Yeah.
I can't hear you.
1990.
1,990.
Is that it? 1,990?
Yeah.
Okay. 1,990. And that's going to be what? Kilograms per meter cubed, correct? Is that right?
Yeah, that's right.
Yeah. Okay. So what is it?
Magnesium.
Magnesium. Yeah, it's aluminum is 2,700. Gold would be 19,300. So I tried to fool you. Tried to fool you by saying it's yellow. It's painted yellow. So it could be terrible laboratory data, and it could be aluminum, or it could be what's magnesium?
17,000.
Magnesium is 1,700. You mean 1,700? Okay. Yes. Easy. So couldn't you have also said that we know that pressure can equal rho GH, correct? So I could have said what? I could have said the pressure divided by the height divided by G. Couldn't I have said that? Right? Yes, you see that? Either way. Yes? So the density would be equal to mass over volume, or would equal pressure over GH. Correct? Either one. Now, let me ask you this. What height would this have to be for it to be gold? It's a great question. What height would that cylinder have to be with this width, with that width? Yes?
Yeah.
What height would it have to be? It's a great question. For it to be gold. Okay? Well, isn't this true?
Yeah.
Isn't this true? So if I'm solving for H, what would H equal? What would H equal? Multiply both sides by H, divide by rho, right? Correct?
Yeah.
Right? So it would be H equals pressure over rho G, correct? Yes. Now, we want it to have the same pressure, right? The same pressure that we had before. We want to have the same pressure. Yes? So what was the pressure? Do you remember? What was the pressure? What was the pressure? What did we solve for?
39,809.
What was that, Katie?
39,809.
39,809. That was the knock at the door when the police came, the significant figure police, and arrested one of my students.
Yeah.
But that's okay though. We forgive you. She's a significant figure abuse felon. Okay, right? So 39,809. All right. So that would be 39,809. This is a great way. I'm going to leave the unit labels off as long as I'm using kilograms, meters, and seconds. Isn't that okay? Right? Right? So 39,809 is pascals, which was newtons in meters, which is cool, right? And then the density is what? What's the density?
1,990.
No. No, the density of gold. This is the question. Let's review. What height would this cylinder have to be gold?
Oh, okay.
And what all I'm saying is you're going to have the same pressure. That's all I'm saying.
Oh, okay.
Right? Is that okay? So
19,000.
it'd be 19,300. Is that right?
Yeah.
Okay. Times 10. So what is 39,809 divided by 193,000?
20.6.
No, 20.6. Well, no. It would be, first of all, does that make sense to you? I mean, that's 193,000, right? 19,300 times 10. So the number's going to be way less than 1, right? So does it make any sense what you said?
Nah.
23 meters. Yeah, so what would it be? It went off?
No, you're good.
Am I good? Okay. So the answer would be, I'm going to write right here. This would be what?
0.21.
0.21 meters. Good. Good. Easy? What would be a different way of doing that problem? Let's say that we wanted to use the old-fashioned problem. We wanted to use simply mass over volume. So can I erase this? We don't know what that is. Okay, so density of gold equals mass over volume, correct? You got that? Easy, right? So it would be density equals mass over pi r squared h, correct? Right? So multiply both sides by h and divide by rho. Are you with me? Okay, so you'd say h equals m over rho pi r squared, correct? Yes? Are you with me? So then h equals what? 125 kilograms over rho, which is 19,300. You should go around in life and say, walk up on people in the street and say, did you know that the density of gold is 19,300 kilograms per meter cubed? You should know that. You should. Like air is 1.21, right? Water's 1,000, right? 2.2 pounds in a kilogram. Those are little things that you should know. You won't have many friends, but at least people who don't want to be your friend will know those things, right? Okay, now, so that's going to be times pi, we'll just say, times 0.1 centimeters. And what does that equal? What's 125 divided by 19,000 divided by 19,000 pi 1.1 squared, right? 0.1 squared. 0.1 squared times pi times 19,300.
0.1
So 125 divided by this product. What do you got?
The same 1.21.
Say, what do you got?
0.21.
0.21.
Yeah, the height you have is 0.21 meters. Excellent problem, don't you think?
Yeah.
We're done? Hey, I love rock and roll. Do you?
Yeah.
Excellent. And we'll leave you with... Oh! I feel so much better. You know, what a combination. Physics and rock and roll, I'm there. Joan Jett, 1982. Look that up.